So the topic for today is piecewise functions. We've worked a lot with functions so far. We've given you like f of x is equal to x plus 2, and they ask you to evaluate when x is 2. It's pretty straightforward because we knew that we would plug 2 in for x, and then we would evaluate and find that 2 plus 2 is equal to 4. Today with piecewise functions, it's kind of within the name piecewise to say that, hey, it's not just, it's a generic function, but then we're going to have a couple of different parts along with that function. So the best analogy I could give to you is a piecewise function is kind of like sorting cattle. So you bring your cattle in, and if they weigh between 100 to 200 pounds, you're going to put them in this pen. And then if they weigh between 200 and 300 pounds, you're going to put them in this pen. 300 to 400, they're going to go in this area. 4 to 5, they're going to go in this area, etc. So to work with piecewise functions, you really need to look at what your x is, and then determine, okay, am I going to this one, or this one, and so forth. So it's kind of many functions within the general function itself. Example number 1, they want us to take this chart. It's the admission to get into a museum. The age under 12 to 50, and then over 50, there are the prices and the discounts for those. And we want to graph this piecewise function showing the museum costs for someone X years of age. Two variables here, and we're going to bring back some old terms that we've talked about before. Independent versus dependent. Now, independent was X or Y. It was the X. And what is our X variable here? It is the age. Very good. Dependent is your Y, and that's going to be the what? The price or the cost. Very good. And your independent always goes on the x-axis. So again, that's our age. And then our dependent is going to be our cost up here on the Y. We got to pick an appropriate scale for this. As we look at this, our ages go from 0 to over 50. We could have somebody live up to 100 years, possibly older than that. So we're looking between 0 and 100. So what would be a good scale to use down below here? Yeah, we could go by tens. That's all right. So 20, 40, 60, 80, and 100 there on the very end. That's fine. Costs, what would we want to use for scale there? And then Peyton, if you would, could I have you hand one out to everybody? Sorry, I should have done that at the beginning. Thank you.
$5.
Yeah, we got $5 there. We could go, are you saying 5, 10, 15, 20? We could. What's the highest dollar amount that we're going to have? 12. So maybe we could go even smaller yet. You could go by twos. If we went 2, 4, 6, 8, 10, 12, 14, I would say that's a good place to go. So let's go 2, so 4, 8, 12, and then 16 if we wanted to. It's about the best we're going to get. We can't go ones or else we'd be way up there with our 12. So 2 would be an appropriate scale there. And now we need to go ahead and graph this thing. Now it says for any child under 12 years of age, we only have to pay $5. So whether we're here at 0 or we're going all the way to 12, it's strictly 5. So from there over to 12, it's going to be 5. Now I should have made that a little bit more obvious, but is that going to be an open or a closed circle there? Open because it's under 12. For the second interval, it's going to be from 12 to 50, and that's going to be $12. So if we go to 12, and that's approximately at 12 years of age, and we're going to go all the way over to 50. There's that one. And then if we go over 50, it's going to be 10. So open circle at 10, going all the way to the right. And there's our piecewise function. Intervals, again, between 0 and 12, 12 to 50, and then 50 and up. The other thing we can do with piecewise functions is evaluate, just like we talked about at the beginning. They want us to evaluate when x is 0 and x is 5. Again, it's the idea. Which area or which pen or which sector are we going to? Are we going to the first one, the second one, or the third one? Well, the format of a piecewise function goes y, comma, if x. So to begin with, you actually go to the end here. And if our x is 0, again, function notation, plug 0 in for x. It's a nice way to indicate what we're looking at here. You know, are we going to go into this first one, second, or third one? Well, are we less than 0? No. Are we between 0 and 5 and could be equal to 0? Yeah. So if x is going to be 0, I know I need to use that one right there. We're going to go into pen number 2, so to speak. And our y value is simply going to be negative 5. How about if our x is 5? First, second, or third one? Jeremiah, what do you think? First, second, or third? Do we fall into this category of being less than 0 if we're 5?
Yes.
We do?
No.
Nope. 5 is not less than 0. We're not strictly less than 5, but we can also be greater than 5, right?
Yeah.
So we're going to go to that third one. And what does it tell us our y value is? Well, it's 2 there. Let's do another one. F of negative 2. All right, Zane. F of negative 2. Which one do we go into? The first, second, or third one?
First.
First one, yes. X is less than 0, so what's my y value?
12.
12. Catching on? You have to identify which one do you go to. They could have 4, they could have 5, they could have 2. Okay? But you essentially start over here on the right and then map back to what your y value is going to be. They give us the graph. Now you need to come up with the piecewise function. Awesome, right? It's almost the exact opposite of what we did for example number 1. In number 1, we went from, the piecewise function to the graph. Now we're going from the graph to the function. So f of x is equal to big set bracket. The template again is y, comma, if x. And I don't know why that, for whatever reason, Algebra 2 students struggle with catching on to that format. It's y, comma, if x. And you can start with whichever one you want to. The first thing I notice is this line right here if I'm working from left to right. And what is that y value? 2, correct? First thing I'm going to put is 2. And now I need to tell that function, okay, that's for what type of x's? Well, it starts here when x is 0, and then it goes to 2. And now I need to be strictly less than 2, but I can be equal to 0 as well. Going to give you another 30 seconds, and I want to see if you can come up with the last 2 statements. Devin, what do we get for statement number 2?
4 if 2 is less than or equal to x is less than
4 if, one more time.
If 2 is less than or equal to x, x is less than.
Awesome. Strictly less than 4, but can equal 2. And then for the third statement, Peyton?
6 if 4 less than or equal to x.
Good work. Y, comma, if x. It's different, you know, it looks complex, but when you break it down, it's not too bad. And now we're going from the function to the graph. F of x is going to equal 2x plus 1 if the x's are less than negative 1. Now, what is this going to produce for us? What is this 2x plus 1? If we graph it, it's going to be a line, correct? So let's just go ahead and start by graphing this thing. Y-intercept is 1. Let's try it again. There we go. So the y-intercept is 1, slope is 2, up 2, right 1, up 2, right 1, up 2, right 1. So if we just plotted 2x plus 1, that would be our line, correct? But now what type of x's are we looking at here? Well, it's everything that's less than negative 1. So now I'm going to take my eraser, and I'm going to go all the way back to negative 1. And is that going to be an open or closed circle there at that point? Well, it's going to be open. So we still have the line 2x plus 1, but it's just for everything to the left of negative 1. Let's try the next one. Negative 3x. Y-intercept is 0. And from that point, I'm going to go down 3, right 1. Down 3, right 1. Opposite direction, up 3, left 1. And again, if we weren't restricted by our domain, we would just graph the line and we'd be done. But again, we want the x's between negative 1 and 2. So I'm going to erase up to there. And then I'm going to erase right there. And go back and look at what should be open and what should be closed. The negative 1, it can be that. So a nice bold dot right there. 2, that one actually needs to be open. Last one, x squared minus 10, if the x's are greater than or equal to 2. What is x squared minus 10 going to give us? What's that shape? Hopefully you're all saying parabola. And you'd be right. Now we could go through our entire process, find the vertex and all that fun stuff. But again, we're looking for the x's greater than or equal to 2. So let's just do an xy chart. Let's start with this x being 2. And then we can do 3. And if we wanted to, we could even take a look at where it's at when x is 4. If I plug 2 in, 2 squared is 4 minus 10 will get me negative 6. If I plug 3 in, 9 minus 10 is -1. Plug 4 in, 16 minus 10 will get me 6. So 2, -6. Wouldn't you know it, it's right there. 3, -1. And 4, 6. Beautiful, right? Beautiful. Looks like a mess, but that's the piecewise function right there. So probably the best process that I have for this is the eraser method. Graph whatever it is and then erase whatever you don't want. Graph whatever it is, erase that domain again, and so forth.
Should you have to graph the other half?
Nope. Because I only want the x's greater than or equal to 2. Same reason why we didn't graph the rest of this line. Same reason why we chopped it off there, and so forth. Getting the idea? It all depends on what that x is. Okay, which pen is it going to go into? We're going to take a look at C and D, but we're also going to do B as well.